In this video, we're going to take a look at a second example where we find the derivative. Here, our function is the square root of x. So we'll find the derivative, find the slope of the tangent line at a point, and the equation at that point. And so, to find our derivative, we will write the definition of the derivative. So f prime of x is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. And when we apply that to our particular problem, we have a limit as delta x approaches 0 of the square root of x plus delta x minus the square root of x all over delta x. If we tried direct substitution, we would get 0 over 0. So this seems like a trickier problem. But in this problem, we might consider multiplying by a conjugate. We have square roots floating around, and so to get rid of those square roots, we might multiply by the conjugate. We have to do the same thing to top and bottom, and so we'll multiply the top by the square root of x plus delta x plus the square root of x. All of that over, we'll multiply the bottom by exactly the same thing. So as long as we multiply top and bottom by the same thing, we have not changed our problem. When we FOIL this out, so our conjugate is a minus, and so we're going to change that sign to a plus. When you FOIL it out, the outer and the inner term, by design, those should always cancel out. That's the way we hoped. So that outer and inner term has square root of x plus delta x and square root of x. The inner term has the same things, but it has a minus sign, and so they're going to cancel out, right? And our first terms, they're the square root of the same thing, and so that square root, it's just going to go away, right? And so we have an x plus a delta x. For the second piece, or for the last, we will have square root of x and square root of x, but one of those was negative, which is why we have a minus x. And on bottom, we have that delta x, and I'm not going to distribute it through, because my hope is that that delta x will cancel. So the x's cancel on top. Oh, and we have a delta x on top and on bottom being multiplied throughout, so those will cancel. We're left with just a 1 on top. And so if we do direct substitution, we get 1 over square root of x plus the square root of x, which is 1 over 2 root x. So that's our derivative, f prime of x, right, is equal to 1 over 2 root x. Now we want to find the slope at the point of the tangent line for 2. So to find that slope at 4, 2, we're going to take our derivative, and we're just going to evaluate it at 4. Plug in an x value of 4 into that derivative. And when we do that, we get 1/4. Great. To find the equation of the tangent line, we are going to take our y minus the y value. So y minus the y value of that point was 2 is equal to the slope 1/4 times x minus the x value of the point, which was 4. That's point slope form, perfectly fine. If you want it in slope intercept, you can solve that for y. If you solve that for y, you get y equals 1/4 times x plus 1. Fantastic. We'll see you in our next video where we'll do a third example. We'll see you there.